Dear math aspirants, right now I have the G Piano 1858-1932 and chapter 4 is the topic of ours and the heading is principle of mathematical induction is here and here the analysis quote is given here. Analysis and natural philosophy owe their most important discoveries to this fruitful means which is called induction. Discoveries to this fruitful means which is called induction. Newton was indebted to it for his theorem of the binomial and the principle of universal gravity. Laplace, here the quotes is here and you can see quotes and the topic is here and introduction is here. Introduction. One key basis for mathematical thinking is deductive reasoning. An informal example of deductive reasoning borrowed from the study of logic is an argument expressed in three statements. A. Socrates is a man. All men are mortal. Therefore, Socrates is mortal. If statements A and B are true, then the truth of C is established. To make this simple mathematical example, we could write 8 is divisible by 2. Any number divisible by 2 is an even number. Therefore, 8 is an even number. Thus, deduction in a nutshell is given statement to be proven, often called conjecture or a theorem. In mathematics, valid inductive steps are arrived and proof may or may not be established, i.e. deduction is the application of a general case to a particular case. General case to a particular case. In contrast to deduction, inductive reasoning depends on working with each case and developing a conjecture by observing coincidences till we have observed each and every case. It is frequently used in mathematics and is a key aspect of scientific reasoning, where collecting and analyzing data is the norm. Thus, in simple language, we can say the word induction means the generalization from particular cases or facts. In algebra or the other discipline of mathematics, there are certain results or statements that are formulated in terms of n, where n is a positive integer. To prove such comments the well-suited principle and is used based on the specific technique is known as principle of mathematical induction. Motivation. Mathematics we use a form of complete induction called mathematical induction. To understand the basic principles of mathematical induction, suppose a set of thin rectangular tiles are placed as shown in figure 4.1. When the first tile is pushed in the indicated direction, all the tiles will fall to be Absolutely sure that all the tiles will fall. It is sufficient to know that the first tile falls, and the event that any tile falls, its successor necessarily falls. This is the underlying principle of mathematical induction. We know the set of natural number n in a special ordered subset of the real numbers. In fact, n is the smallest subset of R with the following property. A set S is said to be an inductive set if 1s and x plus 1 is, you can see, whenever, since the smallest is the smallest subset of R, which is an inductive set, is follows that any subset or R that is an inductive set must contain n. Illustration: suppose we wish to find the formula for the sum of positive integers 1 to 3 follow dot 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 n, that is a formula which will give the value of 1 to 3 when n is equal to 3, the value 1 2 3 4 when n is equal to 4, and so on. And suppose that in some manner we are led to believe that the formula 1 2 3 plus dot 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 plus n is equal to n plus n whole n plus 1 by 2 is correct one. How can this formula actually be proved? We can of course verify the statement for as many positive integral values of n as we like, but this process will not prove the formula for all value of n. What is needed in some kind of chain reaction which will have the effect that once the formula is proved for a particular positive integer, the formula will automatically follow for the next positive integer and the next indefinitely. Such a reaction may be considered as produced by the method of mathematical induction. 4.3 The principle of mathematical induction. Suppose there is given a statement p whole n involving the natural number n such that the statement is true for n is equal to 1, i.e. p whole n is true, and if the statement is true for n is equal to k when k is the some positive integer whole, then the statement is also true for n is equal to k plus 1, i.e. truth of p whole k implies the truth p k plus 1 whole. Then Pn is true for all natural numbers n. Property 1 is simply a statement of fact. There may be situations when a statement is true for all n greater than 4. In this case, step 1 will start from n4 and we shall verify the result for n is equal to 4, i.e. p4. Property second is conditional property. It does not assert that the given statement is true for n is equal to k, but only if it is true for n is equal to k, then it is also true for n is equal to k plus 1. So to prove that property holds, only prove the conditional proposition. If the statement is true for n is equal to k, then it is also true for n is equal to k plus 1. This is a statement's referred to as the inductive step. The assumption that the given statement is true for n is equal to k in this inductive step is called the inductive hypothesis. For example, frequently in mathematics a formula will be discovered that appears to fit a pattern like 1 is equal to 1 square 1 4 2 square 1 plus 3 3 square 1 plus 3 plus 5 16 4 square 1 plus 3 plus 5 7 etc. It is worth to be noted that the sum of the first two odd natural number is the square of second natural number. Sum of the first three odd natural numbers is the square of third natural numbers, and so on. Thus, from this pattern it appears that 1 plus 3 plus 5 is 7 plus dot 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 plus 2n minus 1 is equal to n square, i.e. the sum of the first n odd natural numbers is the square of n. Let us write p whole n 1 plus 3 plus 5 plus 7 plus dot 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 plus 2n minus 1 is equal to n square. We wish to prove that Pn is true for all n. The first step in proof that uses mathematical induction is to prove that P1 is true. The step is called basic step. Obviously, 1 is equal to 1 square, i.e. 1p whole 1 is true. The next step is called the inductive step. Here we suppose that p whole k is true for some positive integer k, and we need to prove p whole k plus 1 2 is true. Since p whole k is true, we have 1 plus 3 plus 5 plus 7 plus dot 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 plus 2k minus 1 is equal to k square. Consider 1 plus 3 plus 5 plus 7 plus dot 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 plus 2 k minus 1 whole plus 2 k plus 1 whole and 1 bracket closed is equal to k square plus 2 k plus 1 whole and k plus 1 squared. Therefore, k plus 1 is true, and the inductive proof is now completed. Hence, Pn is true for all natural numbers n. In next video, we will discuss, for example, 1 and many more, so on. Till then, thank you.